Network architectures. In this nugget, we revisit the subject of networking, which certainly forms the core of any information technology professional's life. We'll start by differentiating between the two primary network types, or network architectures, and those are the peer-to-peer and client-server models. After we understand that, we'll start to put together these networking components, hosts, switches, routers, firewalls, kind of like Lego blocks, and learn specifically the role of those network connectivity devices when we build out a local area network or perhaps a wide area network. Finally, we'll get really practical and look at how we put these connectivity devices together in practice in physical form. Specifically, we'll look at the components of a typical wiring closet and server room and understand again the major parts and pieces. As an IT sales representative, you're going to be overcoming or trying to overcome some skepticism on the part of some IT professionals that you know your way around, for instance, a server room or a wiring closet. Therefore, the information that we present in this nugget, I think, is of particular import to you in your careers. Let's get started. Network types. Some of the words in vocabulary can step on each other to a degree. Some would consider a network type to be a network architecture and vice versa. This whiteboard is meant to immerse us into the subject by reviewing some of the things that we've covered in previous nuggets. A computer network is simply two or more hosts or computer systems. They don't have to be PCs specifically. They can be switches, routers, network-enabled printers, file server appliances, the list goes on and on. These devices are formally called hosts. This term hosts dates back historically and is tied very deeply to a networking protocol, actually a protocol family called TCP/IP that we'll cover in some detail shortly. But anyway, a network is two or more hosts, not just PCs, that are either wirelessly or in a wired fashion connected together in the name of sharing resources. Once we build out this network, depending upon the size of the implementation, we could call the network a local area network or LAN, a WAN, and there's even in-between terms like metropolitan area network, which we won't really talk about because it's not on the CompTIA objectives. We'll recall that the local area network is a network that's under a single administrative authority. Specifically, LANs are defined as being consistent within a single geographic area. Maybe a business that occupies a floor or part of a floor of an office building. The extent of their network is their LAN. Next door, there's another business. They have two or more hosts sharing resources. They have a LAN. As we talked about earlier, geographically distributed organizations may have multiple sites in multiple cities, states, or countries. Each of those local sites is a LAN, but then the entire organization is a LAN in as much as it's a single administrative authority, single ownership, etc. Now, the chief difference between LAN and WAN are these long-distance links. Whereas within a LAN, we typically have very high-speed connectivity, 100 megabits per second, hopefully even at the core at least, 1,000 megabits per second. Now, we're not quite there yet with wide area networking connections to get up to anywhere near that kind of speed. Therefore, network administrators always historically consider it a challenge to provide the fastest, most reliable, and most secure wide area network connections between those LAN sites. Within a LAN, oftentimes, especially nowadays, the organization is going to present not only the traditional wired Ethernet access, but also 802.11 wireless access too. Wired and wireless. Wireless access is referred to as the WLAN. The WLAN physical infrastructure is going to consist of, and you should know this by now, your wireless hosts, which would be, say, laptops, slate computers, perhaps smartphones, any client-side device that's going to access the WLAN, your wireless access points or WAPs that associate with those hosts and are in turn plugged into the wired LAN proper. You see? Yet another network type is what's called the virtual private network, or VPN. This is meant to give remote users, that is, folks who are outside the organizational jurisdiction of their LAN, secure access to corporate resources from a very unsecure medium, the internet. Many of you, especially those working in IT sales, are very familiar with VPN because, for instance, from your hotel room or maybe a public Wi-Fi hotspot, you would open your laptop, log into Windows, fire up your VPN client, create that secure tunnel across the public internet to your organization, and then do a logon into your organization, and you can have access to all of those private resources over a secure tunnel. VPN is another subject unto itself. I mean, to an end user, it's a mild inconvenience because it's a separate connection. You have to be connected to the internet first of all, and then you have to bring up the VPN pipe. And number two, VPNs, because of the overhead involved with all of that security, they tend to be much slower than an ordinary connection is. So VPNs tend to frustrate more than help the end user, but certainly as far as regulation, compliance, and just information security, VPNs are crucial to keep security high when we're giving remote users their connections. And like I said, entire books, entire courses have been written on building and managing VPN architectures. It's a huge subject. I mentioned we weren't going to talk about the MAN. MAN is the Metropolitan Area Network, and this is meant kind of as a bridge between the LAN and the WAN. MANs are used, you see the M means metro or metropolitan, in the case where an organization might have multiple sites within a city. So they're not so geographically dispersed as to involve hundreds or thousands of miles. Nonetheless, these are physical campuses with their own LAN high-speed connectivity. And what a lot of companies do nowadays in a MAN environment within a city is that you can purchase what's called a Metro Ethernet connection that gives you Ethernet speeds. We're talking 100 megabits per second between those campus locations, even though one location may be on one side of your city and the other on the other side of the city. It's an excellent way to do business because in this case, using a technology like Metro Ethernet, truly this entire citywide collection of nodes or sites is running at a single LAN speed and can be configured to appear internally as a single LAN. Very hot technology indeed. Now let's delve within one of those aforementioned network topologies or types, the LAN, the MAN, and the WAN, and look at the specific arrangement of computers within that architecture. They fall along two main lines. You have either a peer-to-peer LAN or a client-server LAN. Now, what's the difference? First of all, a peer-to-peer LAN is where you have a computer network in which each host or each connected device is a peer of any other connected device. So in this case, let's say we have a very small business that has maybe 10 or 11 PCs total. The owner of the business can't afford a dedicated IT administrator, so he or she maybe outsources, hires out, or tries to do the work himself or herself. What do you have? Well, chances are all of these hosts are running a client operating system, let's just say Windows 7. So therefore, each person gets a host, each person has their account defined locally on that system. The administrator account that's built into any Windows system is local to each system. And let's say we're plugging along and one of those employees figures out the administrator password. If these hosts were set with the same password, then this user can sneak over here and log on as administrator over here and own the network. Alternatively, if, for instance, a really bad worm comes out that's crashing computers all over the world, if the owner of this small business wants to make an update, he or she is going to have to visit each one of these machines individually. You see the theme? In a peer-to-peer network, there's no central management. The management is considered decent if it's a small enough network. In other words, your home network, perhaps you have a wired or wireless router and a cable internet connection, and inside you might have two PCs, an Xbox 360, a PlayStation 3, a couple iPhones, etc. I mean, that's getting up there in terms of the number of devices. But because you are just a residential user and you know everybody who's there in your home who's using the devices, it's kind of a set it and forget it operation. However, in business, it's a much more problematic issue to maintain a peer-to-peer network because any change you want to create, for instance, this example I gave of an employee compromising the administrator password, you would have to then, as a network administrator, visit each one of these separate boxes to change the password. If you wanted to set up a new user account, you'd have to do it manually. Basically, peer-to-peer, unless you've got 10 or fewer PCs, is going to be almost unworkable nowadays in a business environment in terms of keeping up security, keeping up ease of administration, etc. By contrast, the client-server network model involves one or more host computers. Let's say we have 3 Windows 7 client computers, and we also have at least one other PC. Remember the server role? This is generally going to be a more buffed up machine with more RAM, more processing power, and so forth. This would be running a server operating system proper, like Windows Server 2008. The idea here is we want centralized management of resources. In other words, when we bring new employees on board, we create their accounts once on the server. And check this out. Theoretically, the user can log on to any associated client workstation using that single account. This is a feature in client-server networking environments called single sign-on, or SSO. It gives the user a lot of flexibility because they can be more mobile, and it certainly gives the system's administrator flexibility because password resets, disabling accounts, changing passwords like we saw up here earlier, can all be done in one spot. Similarly, sharing resources in a peer-to-peer environment is very problematic because you have to share those resources, whether the resources are a connected printer or a shared folder. You have to do all that manually on a PC by PC basis. In a client-server environment, you share those resources centrally on the server and administer in one place instead of in several. I think you've got the idea. Common buzzword you'll find for in-between sized networks is what's called SOHO. SOHO stands for small office, home office. I, for instance, run a SOHO shop. I work out of my home. So I'm a classic kind of poster child for this kind of topology. Here we're dealing with a very small number of users with a relatively small number of client devices. The reason why I said that SOHO environments are kind of on the border between peer-to-peer and client-server is that sometimes you as a systems administrator need to weigh the pros and cons of ease of administration that's going to tend you over to the client-server and is also going to involve an extra expense, isn't it? Because you'll need at least one dedicated server machine with server license, and then you'll have to pay client access licenses for each host, at least if you're using a closed-source proprietary system like Microsoft operating systems. You'll have to outweigh that with going the cheaper route, doing peer-to-peer, which on its face doesn't seem to require as much configuration, but over time probably will require much more effort because of the PC by PC deal. That's my technical word of the day, by the way, deal. What you're looking at now is a Microsoft Visio diagram that I found at FileDen.com. It's going to serve as a good example, kind of a case study that's going to allow us to tie together much of what we've been learning over the past few nuggets. Above all else, friends, I want to make sure that as we're proceeding with this course material, that it doesn't seem like it's all a bunch of disjointed, disconnected information. Truly, nothing could be farther from the truth. I want you to start taking these building blocks, these individual nuggets of information that I'm sharing with you, and starting to put them together in a cohesive manner. What we're seeing here is a network topology diagram for a fictional company, and the diagram is so large you see it's being cut off on my video capture, and that's fine. Ignore this stuff over on the right. Let's just focus on these two areas here, the main administrative offices and the administrative IT building. So let's imagine furthermore that the main administrative offices is its own building. In other words, the campus consists of 2 buildings, and this one perhaps 2 or 3 floors, and then there's a separate outbuilding for our administrative and IT folks. Now, how does this stuff work in practice? What you're seeing first in the main administrative offices are partitions or departments. Any network administrator who's tasked with building out a local area network needs to think of things like organization. Are we going to partition the office on the basis of job function? Are we going to do it on the basis of department? It looks like in this case it's a little bit of both. What you're seeing here are work groups. For instance, there's a design office that consists of 6 PCs and a network-enabled printer. Next door, we have an accounting office with 5 PCs and a printer. And then we have individual offices for the brass of this company, the CEO, the administrative assistant, the chief operating officer, the directors, and so forth. And you notice that each one of those people, and this is pretty consistent with my experience too in IT, they have their own dedicated printer because they're special. You'll notice that this network also involves a big printer, one of those big old multifunction shared printers. Chances are Print 04 and Print 05 are also bigger multifunction, but it looks like this one is available to everybody in the main administrative office. We also have a network-enabled plotter and a server. However, it looks like the IT proper is centralized in this environment to the administrative IT building, which could be a building next door on the campus or maybe a little bit down the street, whatever. And in this case, we have the shipping department with some client desktop PCs and a shared printer. Then we have the IT office that has some workstations. There's the server room with some servers. There's a backup server. And then this icon that looks like a brick wall denotes a firewall. CSU-DSU is a special type of wide area connectivity device. Let's just pretend this is a router. And then we have the internet. So that gets the company out onto the internet and back from the internet. Now, how does this work more physically? Physically, each of those users in those office is going to have his or her computer with their associated Ethernet card, right, plugged into what's called an Ethernet wall plate, also affectionately referred to as a wall drop or wall port. It looks something like this. Cable dressing refers to making sure that the number of snake-like cables that the users in the organization see is as small as possible. We want to be as surreptitious as we can in terms of not having cables snaking all over the office. We want to get them to the wall drop as unobtrusively as possible. What you're seeing in this picture in the upper left is both sides of the wall drop. On the right side, this is the Ethernet cable that goes to the user's computer, and then on the other side we have a matching Ethernet cable that snakes through the wall, through the ceiling, through the floor, however you're routing cables to the telco closet. Alright, so for instance in the design office you would have at least 8 Ethernet drops spread throughout the room. Where are those cables going to go? Well, what's not shown in this network diagram and really should be here is what's called a telco closet or a switch closet. I said before, let's imagine this as being a multi-floor office. Considering that this isn't all that many PCs, let's just change that and consider this to be a single floor in an office building. The idea here is that you want to physically aggregate the cables from your floor into one spot through the walls. So this administrative assistant has an Ethernet drop and through the wall the cable goes. Over here in the accounting office, those wall drops go into the wall or ceiling and so forth, and eventually terminate in the telecommunications closet and collapse upon one or more switches. Switches are intended to aggregate network connections. We'll talk more about the specific function of the switch in just a moment. Now, once you've aggregated everybody's connection into this rack of switches, how do we get, for instance, out onto the internet? How do we, for instance, log onto the network? Well, in this situation, in this diagram, all of the IT stuff is next door. So what we're going to have to do is get our cable from the telco closet here in the administrative offices next door to the administrative building where their main server room is and where their main connectivity devices reside. How that typically works is by use of fiber optic connections and conduit. What you're seeing in the upper right is a mass of Ethernet cable, traditional Category 5, Category 6 cable. You can tell by the plugs, I hope. And you're also seeing some fiber optic connectors with fiber optic cable. Now this is super high-speed cable that can go for much greater distances than traditional Ethernet cabling can. Fiber optic is often used to uplink or connect one switch to another and is certainly used as a backbone connectivity when you're going from one building to another. So for instance, what you're seeing in the lower right here are examples of conduit. Conduit is simply a hardened material, a tube, let's say, through which you run your core fiber data line, and this is what's going to take your cable from one building to the next. Traditionally, conduit is placed underground to a certain degree, and you want to make sure the conduit is strong such that a landscaper doesn't pierce or otherwise disrupt the very delicate fiber cable inside. Once we get the fiber cable to the administrative IT building, we're going to terminate that cable into a switch, and here's where we're going more from the access layer of the network, where most everybody is just getting online, to the core of the network in our IT office and our server room, where you have your server racks and so forth. And these are going to be really high-speed connections, these switches. And to get us out onto the internet, we're going to need to connect to a firewall that serves to filter traffic, and then the router actually is our outlink and inlink to our internet service provider. So that's the name of that tune. Let's fill in some of the gaps now and look at the connectivity devices that we're expected to understand for the CompTIA Strata IT for Sales exam. The switch, as I said a few times, is a physical device that's meant to aggregate network connections. You might have an 8-port switch or a 16-port switch or a 32-port switch. The number of ports on a switch is referred to as the port density of the switch. You also want to look at the reliability of the switch. Cisco Systems is pretty much the world leader for both switches and routers. The switch is used to provide dedicated bandwidth on each port, such that if you have a 16-port switch that operates at 100 megabits per second, you're guaranteeing every device that's connected to a port on that switch has the full 100 megabits per second. In the olden days of networking, you had a connectivity device called a hub, and there every port on the hub shared that 100 megabits per second. It was a very inefficient way to go. Remember earlier when we talked about CSMA with CD? That's the Ethernet networking access method, such that two hosts that want to communicate will quote-unquote listen on the wire to see if it's clear to go to avoid these packet collisions. Well, packet collisions aren't going to happen on a switch because the switch maintains intelligence, if you want to call it that, to prevent those collisions from happening. It breaks your network into what are called collision domains. Moving up the scale, a router device is a piece of hardware that's used by administrators for two reasons. One, this is the device needed for internet access. And number two, it's used potentially to divide a network into segments. Now, what do I mean by that? To come back to our diagram, what we could do if the design office and accounting office had 100 people instead of just 7, we might want to use a router to put each of these offices on their own private local area network. But just consider it for our purposes that by doing that, putting the design office and accounting office on their own mini local area networks, they would still have full access to the entire network like they would normally. But as an administrator, it allows you to do things like throttle traffic, to give priority to, say, the accounting office during some times of the day and design office for other parts of the day. It allows the network administrator to do security restrictions. For instance, these different departments may have different network access requirements. By creating what are called virtual local area networks, or VLANs, the administrator is able to do that quite easily. So routers are actually very, very handy indeed with most networks. Similarly, you should never be caught without a firewall. A firewall is hardware or software that's used to screen inbound and outbound traffic. Particularly important on the network perimeter when we're involving that vast, dangerous jungle known as the internet. With print management, we can either have the print queues managed in the circuitry of the print device, or we could do it on a server computer. And then, as we've discussed, a WAP is a wireless access point that serves as a bridge between the WLAN and your LAN. The final exam-related subject that we need to cover in this nugget is that of components of the wiring closet, also called the switch closet or the telco closet. Remember I mentioned that in a local area network, the point is to give the users their Ethernet access, but ultimately collapse those cables in a most aesthetically pleasing way. Not to mention when you're dressing cables properly, it's reducing fire hazards. You're bringing all those cables into a central location. In a multi-floor building, for instance, you typically have a floor-level telco closet. So you have a switch stack in each floor, and remember I mentioned fiber optic uplinks between those switches, and then ultimately you collapse those connections down into your server room, to your core switches, your core firewall and router, and then out to another building, maybe another local area network in another state or country, the internet, the list goes on. Now physically, putting those devices together involves things like space efficiency. That's why these so-called server racks or telecommunications racks are so handy nowadays. When we deal with appliances like servers, rack-mounted servers, switches, routers, they're going to be of a standard width and a standard height. The width is almost a moot point because any hardware vendor worth its salt is going to know the traditional width of a server rack. The height also is standardized. That is to say, if you go to buy a server or some other rack-mounted device, it'll be advertised as being a particular number of units in height. A rack unit, also shortened to U, is 1.75 inches. That's the standard dimension. So the thinnest devices are going to just be 1 unit tall. As you see in this diagram, you see these are fairly thick Dell PowerEdge servers. Look at these. Some of these are just ginormous, but 2 or 3 U's is not uncommon for any server. But switches, firewalls, routers, in most cases, are just a single unit tall. Now, as far as aggregating those wires, you need to understand what a punch-down block is and what a patch panel is. Remember I mentioned that the cable goes from the wall port through the wall ceiling or floor, potentially subfloor, to the telco closet. Well, what happens specifically and physically to that cable? Does it just plug directly into a patch panel? No. You need what's called a punch-down block. So what you have is this braid, these braids of cables that have been aggregated through your space, your plenum space, into your telco closet. And each of those braids is typically naked. That is to say, the ends have the 8 wires exposed. You're not using the RJ45 plug. So the purpose of this punch-down block is to give you a surface to punch in each of those Ethernet cables with those 8 wires spread out in a particular configuration. Now, if that sounds complicated or tricky to you, it kind of is. There's a special tool that network administrators use called the punch-down tool that makes it easier to take these naked wires, punch them into the back of this punch-down panel, which is also called a 110 panel for historical reasons, and serves as an anchor point for those cables. Now, that process of punching down a cable is called terminating a cable because you're kind of ending it, like you'd get on a train, and a train has many stops along the way and then terminates or ends at a final destination. Similarly, your user's computer plugs into their wall jack with one cable. The inner cable goes along through the plenum space into the telco and is terminated in this 110 block. So that's the complicated part. Then it gets much easier, actually. On the other side of the 110 block, you have a cover here called a patch panel. And as you see, it gives you a really nice collection of RJ45 ports that correspond to all of the terminated cable on the back. The purpose of the patch panel is for ease of organization. You notice that this particular patch panel has little ID markers where you can denote the specific drop that goes with each of those patch ports. A poorly designed network is going to be a spaghetti soup where a user in his or her office has a problem, and then you need to figure out which port on the patch panel corresponds to which user's Ethernet drop. That's such a big mistake. When you're setting up a network, make sure to clearly mark the wall plate with an ID number in the user's office and also denote that wall plate ID on the patch panel so you always know where cables terminate. From the patch panel, this is where you have a third Ethernet cable come out that goes into the switch proper. The patch panel doesn't do anything other than organize these network connections. Let me show you some more pictures to make this clearer. Here we're out at Google Images again. There's a typical punch-down tool. It's got an interesting head to it that kind of looks like a screwdriver, and it's meant to literally drive those naked cable wires into the 110 block. Here's an example of some Ethernet cables that are punched down into a block. This one is not a particularly good example. It's very old. It's time-stamped 2002, but you get the general idea. What you're seeing here is a Visio diagram that I downloaded from Microsoft for free. If you do a Google search for Microsoft Visio templates, They can give you just about any starter diagram you can imagine. This one I thought was useful because it gave us a really nice schematic of a typical server rack, what you're likely to see on one of those racks. Visio is such an important tool for systems administrators and network administrators. In particular, a server rack like this, you can not only annotate as you see here, but you can actually collect metadata about all of your devices and store them in a database for querying. Anyway, this particular server rack, let's start from the top down, gives us rack-mounted connections like a surge suppressor power strip. You can get those in a rack format. This one has a patch panel built into it, so you can bet if we swiveled this around 180 degrees, you'd see a whole bunch of cable braids coming out that have been punched down, and they're coming in from various locations throughout the campus. This looks like a 4U cover. Maybe this is just unused space. Now you're wondering about the monitor. Some shops will include a monitor right on the rack. Of course, this facilitates the administrator being able to approach the server rack directly and do work on it. Other systems administrators forego the monitor and just have straight up racks filled with appliances and then connect remotely into any device that they need to administer. When you do have a monitor here, of course, there's the issue of how are you going to do input, right? Keyboard and mouse. I'll show you a picture in just a second. You oftentimes can get a slide-out tray that includes a small profile keyboard and integrated mouse. You also have the question, I'm sure it's coming to your mind, well, okay, cool, you've got a keyboard, mouse, and monitor, but in this case we have at least 4 servers. How do you know which server the monitor is connected to? That brings up another rack-mounted unit called the KVM switch. That stands for Keyboard Video Mouse. That's a really handy technology that you can literally press buttons to switch the keyboard, video, and mouse ensemble from one device to another on the rack. Now you notice that these are all marked with rack units and they're annotated in a fictional way, of course. Server 1, Server 3, Server 4. This one also has a router on it. Note that the management port is indicated. As a systems administrator, keeping this metadata is so crucial because when you, for instance, have a problem and you need to make an emergency connection to a router, you don't want to be hunting and fishing around to find out stuff like the management IP address for that router. This could be a network storage appliance. I'm not sure exactly what it is. Down here at the bottom we have a 5U power supply, also called an uninterruptible power supply, also called a UPS. We've talked about those already. Now to look at some pretty pictures, what you see in the upper left is a slide-out keyboard tray, very low profile. As you see the handle here, you can slide the monitor right down flat to keep the server rack closed and locked for security reasons. And then you see the cable braid here. What this is meant to denote is that many times these units have the built-in KVM connectivity, such that you have a master cable, a master video, keyboard, and mouse plug. And then it goes on from there. We don't need to go into the specifics, but the KVM allows you to control multiple devices. Let's see, what else do we have? This looks like a traditional Cisco router. They're nothing to look at, really, when you see them on their face. What we see on the upper right is a stack of Cisco Catalyst switches. Remember, I mentioned that switches are differentiated from each other by their port density. In other words, how many Ethernet ports they have, how many fiber optic ports are there for uplinks or direct connections, and so on. In the lower right, we have, let me adjust the picture for you a little bit better, a real live server rack, and you can see even the front of these can get kind of messy, especially stacks of switches with live Ethernet cables. These are fairly well dressed. You see that each bundle of Ethernet cable has a Velcro strip around it to kind of create a ponytail. That's a good idea. There are websites out there that show just disastrous cable situations, just like literal waterfalls of network cabling. And that by definition is going to make troubleshooting almost impossible. Network Architectures Review. In this nugget, we solidified our network-related terminology in terms of understanding the distinction between the LAN, MAN, and WAN, and then more granularly, the specific network types, the pluses and minuses of the peer-to-peer or client-server networking models. We then looked at some Visio diagrams that gave us some, I think, really good real-world experience with understanding the role of network connectivity devices such as switches, firewalls, and routers. And then moreover, we looked at the specific path that these network cables take from the client computers to the telco closets, to the server rooms, and then ultimately out onto the internet. I hope that this has been informative for you, and I'd like to thank you for viewing.